All right. So there are two things that we're going to be doing today. First, we're going to rotate this shape here around the x-axis. So like we don't have circles as our cross sections. We're going to have like washer shapes as our cross section. And the second thing we're going to do is we're going to rotate this around the y-axis so that we get a like bunt cake shape looking thing. Um, and we're going to use cylinders instead of circles or circles with holes out of them. All right. So let's look at the circles with holes cut out of them. All right. So rotating this around the x-axis. Um, so like here, it's gonna just be. I mean, that'll be a full circle. But the rest of them, let's put in the negative parts. Are gonna be circles. So like this part is colored in and this part is part of our thing, but that part isn't. So like we got a donut or a washer or whatever shape like coming around here. Ugh. Right. Like the middle here. This is not part of our volume, but all of this stuff is. Um, so if we look at some circles, circles, quote unquote, essentially to find the area of this, we're just going to take the big minus the small. Big minus small. And then, didn't want to do that. So then the big, right, that's the full radius, right? That's for that right there is the radius. And then the small, that will be the radius. So big is going to be pi radius squared. The radius in this case is the top function, which is g of x. And I don't really need this to show up. And the small is going to be pi r squared, but it'll be f instead of g. Squared. That's what I'm missing. All right, so I guess we don't really need this, but it's not the worst thing in the world. Right, on the axis, we're gonna have the most area, and it's gonna be going down until right here it's very tiny, right there, the area will be very tiny. So our integral will be between 0 and pi over 4. Of the area. Now, if you look in the book, and you should look in the book, this is example number 3 on page 401. It shows you a nice little trig identity. I'll just kind of. All right, so we have the area of pi sine minus pi r squared minus pi cosine. So like essentially we can factor out the pi. and this will always work. Our formula essentially for this, I'll type it because that's going to be way easier. So the area is pi times the integral from a to b, whatever those are, of big R minus little r dx, where r is the big, big R is the radius of the larger circle and little r is the radius of the smaller circle. All right, let's look at a Bundt cake. Okay, so we have here sine of x from 0 to pi, and we are going to rotate this around the y-axis. So like our bottom is going to be there, and then the top, I mean, we're going to have circles cut out of it again. Like we could certainly do this with washers, but it's going to be a little tricky because in order to do that, our big R would be this distance, and our little r would be this distance. We can do that. If we turn this into like inverse sine, y equals sine inverse of x, I'll just type arc sine. And how would I do this? Y equals arc sine of x plus 1, no, plus pi. Let's try that. And let's go negative. There we go. We could use this. We'd use arc sine of negative x plus pi as the top, and arc sine of x is the bottom, rotate it around the x-axis, and do exactly what we did. But you need to be able to get to that, and it's kind of annoying. So the other way is we can do this bit. Like that's going to be our, we're going to have a little dx on the bottom here. And then we're going to rotate this around. Like, and it'll be a little cylinder with an empty cylinder, but like a tube, cardboard tube, so to speak. All right, let's take a cylinder. And we're interested in finding the volume of this, except, there's a hole cut out of the middle. Well, that was that was less good. So we're gonna unroll it, right? And we get a rectangular prism. The height. All right, we have 3 measurements. We have that little bit right there, and that's dx. We have the height, and that's f of x. And then we have the length here. And that one's the tricky one, except it's not really all that tricky. It's the circumference of this circle. So we know the radius, which is x. So this is going to be 2 pi x. All right, so when we put all that together, we will get the integral between 0 and pi. Of 2 pi x f of x dx. and that would be the volume of that bundt cake pan that I'm calling it. Bundt cake, right? That thing, not quite that, but you know, close enough. All right.